this, but still you should start from right onwards. Okay, from this point ki, okay, this is something that we will looking forward for our 14th Gen exam. Good evening, Mishpa. So number 1 is units and dimension. Second one is motion in a straight line. And the third one is motion in a plane. When it comes to this third topic, which is motion in a plane, two topics are excluded. Number 1 is circular motion, and the other one is relative velocity in 2 dimension. Okay? So you should prepare it very well. Okay? Today is 5th of Jan. I guess you have plenty of time. Kindly utilize it as maximum as you can. Is that okay?
Yes, ma'am.
Yes, ma'am.
Take care. Now let's start. So today we will discuss about relative velocity. Okay? What is relative velocity and whatever the thing is. So can you tell me about the velocity? What do you mean by velocity? Huh?
The rate of change of displacement with respect to time.
Okay. Very good. So this is our today's topic, and we have 2 words over here, out of which you know velocity already, right? We need to understand what is relative. So as we all have relatives in our life, right? We all have relatives.
Yes, ma'am.
And the one thing that they do very nicely, that they do compare you, right? Whether it's your 10th result or 12th result, they will call you, they will ask you about your results, and they will say ki, oh, she scored lesser than the Sharmaji's son or Sharmaji's daughter, right? There's going to be this kind of like normal. This is normal for them. This is their norms, which they always do, right? Or is it just my experience?
It happens, ma'am.
It happens, yeah. So basically, relative word always, take one thing with them. One thing they always do one thing, and that is comparison. So you can connect that physical scenario in our physics also. That whenever it is relative velocity, now, so we are comparing velocity of one thing with another thing. For example, I am telling you, ki, bhai, this is a man, and he is running with velocity, let's say 10 meter per second. It's okay. He's walking. He's running 10 meter per second kind of thing. But if I'm saying to you that this man runs 10 meter per second more than someone else, so this comparison, now this 10 meter per second is a relative velocity when I start comparing the velocity of one person with another, right? Whenever there is a comparison, there is something like this key, person A is moving more than this much with as compared to person B or something like that. Are you getting my point? So whenever there is a comparison involved in a statement, it associated with the relative velocity. Is that okay?
Yes,
In a
ma'am.
very
Yes, ma'am.
okay, so in a very layman language, you can understand it like this. Just wait a minute. Yeah. So एक second. Yeah, now it's fine. Now you can read your comments and everything. Okay. So let me give you a few examples. For example, we have this car over here. Let's not make the car person is nice. So I said ki this person is moving with 10 meter per second. It's fine. But if I'm modifying my sentence like this, ki person A is moving 10 meter per second more than the person B, then it is relative velocity, because what I'm doing, I am telling you VAB. It is going to read like this: velocity of A with respect to, WRT stands for with respect to
Velocity of B.
velocity of B. Okay, and there is a proper mathematical way to express this thing. You can write VAB as VA minus VB. Whenever there is nothing mentioned like this, VA or VB, so this is something very uh, by default kind of thing. Here it is ground. Whenever you never mention that this object is moving with respect to what, if we are not mentioning that with respect to, then it is always by default you will go with the ground. Okay, this velocity is with respect to ground, this velocity is with respect to ground, so there is no need to mention it. It is quite obvious. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Okay. And as I always said, ki whenever you are getting involved with a vector, be very sincere about the directions, and for that always follow the Cartesian coordinate system. It means whenever you are moving in right direction, go with the positive. Whenever you are moving in the left direction, go with the negative. Moving in upward direction, again positive, and in downward direction it would be negative. So that's how you deal up vector in the terms of direction. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. Uh, if I do a classification on the basis of questions that I'm going to deal with, in this chapter, then there would be few problems like rain, man problem, or there would be umbrella women problem, quite similar one. But okay, we have this kind of question, na? And then we have थोड़ा सीधा line खींचते हैं. Wait a minute. एक second, भाई. Okay, my screen is not responding. So basically, the other problem that we are going to see is river swimmer problem, and then after it, there could be aeroplane, wind, so many problems. But these are quite famous one. So basically, इसमें कुछ ऐसा there is nothing special or different about the dynamics of the question. But the thing is कि we are going to study these cases. For an example, uh, rain is falling like this, vertically downward with some speed, with some velocity, and a person is standing over here, or holding an umbrella. So the question would be like this: कि in which direction this person should open the umbrella in order to get safe from the rain. ताकि वो गीला मतलब बच जाए रेन से, तो किस डायरेक्शन में उसको अम्ब्रेला खोलना चाहिए, ऐसा कोई क्वेश्चन आ सकता है. ठीक है, तो वी हैव दीज काइंड ऑफ क्वेश्चंस whenever we are discussing relative velocity in one dimension or two dimension. There is one simple rule that whenever you are discussing anything, for an example, I am discussing in which direction this person should hold the umbrella. So for that, I am considering this person, right? I am studying this person. So whenever we are solving some problem for us, or for in meanwhile we are considering us at that place, we will consider us in the rest always. So whatever the velocity that I have, I will use that velocity. For an example, let me give a situation. For example, this rain is falling with velocity 10 meter per second in negative y direction. So you can write it as minus j cap, right? Now this person, let's say, is standing on a platform which is moving with velocity 2 meter per second in the I cap direction. Okay. So if I'm asking you in which direction this person should hold the umbrella, so what will you do? You will draw a Cartesian coordinate system and just draw the vectors over here. So you will say ki ma'am, rain in this direction, right? This is VR, minus 10 meter per second. And this person is moving in in positive x direction like this. Okay, that's cool. Yeah, V of man, let's say 2 meter per second. Now the question is ki in which direction this person should hold the umbrella in order to save himself. So I think the procedure is very simple. Do like this. Whatever the velocity this man has, just reverse it. Just reverse this velocity and do a vector addition it with velocity of rain. So you just find the net velocity over here. It is vrm, velocity of rain with respect to man, and opposite to this direction, person should hold the umbrella in order to save himself. So this alpha would be your answer. Are you okay with this? Do we get this? Huh? Do we get this?
No, ma'am.
Okay. See, let's say I am saying ki there is a person who is moving on a platform, and that platform is moving with 2 meters per second in x-axis, right? The rain is falling down with some velocity, let's say 10 meters per second. Now I am asking you, ki, please find the angle alpha, or at that or a particular angle in which the man should open the umbrella in order to save himself from the rain. So for that, you need to calculate the relative velocity of rain with respect to man, because here man is also moving now. I think you should imagine it in a physical scenario. Let's say you are moving, you're riding a bike or something, and then rain is falling. So you are getting the rain in some inclined direction now, at some angle, even if it is falling directly downward, right?
Yes,
Have
ma'am.
you ever experienced it? Yeah. So then you are not supposed to open the umbrella in the vertically upward direction. You need to make some angle with the vertical in order to save yourself, because rain is falling not directly over your head, but I think making some angle and it falling on your face with some angle. So you need to save yourself by opening the umbrella in the opposite direction to it. So in these kind of questions, we need to find out the relative velocities first. So for that, whatever the velocity a man has, just reverse it and do the vector addition of that velocity with the rain. Is that okay? Or should we do some questions to get the hang of it? Hmm? Should we do some questions?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay. Okay. Let's start with a simpler one. Um, this is the direction of velocity of rain. Okay, 40 meter per second. Then here we have a person. Let's say he's sitting on a cycle, something like this. This is a cycle. Okay. Hmm. There's one more person. Okay. The cycle is moving with 30 kilometer per hour. Let's change it also. Kilometer per hour. Now find the angle with vertical. Okay. Okay. Find the angle with vertical in which direction that person should hold the umbrella. ठीक है, umbrella किधर hold करना चाहिए? ये वाले person के पास umbrella है. In which direction? Try to find it out. Okay, Misbah, just wait for a few minutes. I'll explain you. Okay? Don't worry. Okay, you have 1 more minute to solve this question. That is, right now it is 6:08, and you will answer me about 6:09. Is that okay? Otherwise, I will solve this question. Is it done, beta? Have you got the answer? Anyone? See, okay, I'll explain you again. Don't worry. See that number of steps are very simple. Whenever you are dealing with a relative velocity, just remember one thing. Just for an example, in this case, I want to calculate the angle at which this person is supposed to hold the umbrella. So this person is your observer, right? And this person will always consider himself in rest. So with whatever the velocity this person is moving, let's say in this question it is 30 km per hour, he will add this velocity to the rain. He said this is the original velocity of rain, 40 km per hour, right? He will put his velocity on the rain in opposite direction, right? So he said the velocity of rain is this because he considered himself in rest. And then you will find the resultant vector, this thing. So for an example, like this is the angle which we need to find out, okay? And as you can see, this is also alpha, na, vertically opposite angles. So this entire, yeah, let's say this is point O, this is point A, this is point B. OB is 40, OC is 30. So OC is also equals to AB now. It is also 30, right? And
Yes,
whenever I need to find some angle, I will always find 10 of that angle, right? 10 theta, which means perpendicular by base. And that would be AB upon OB, which would be 30 by 40, which means 3 by 4. That's it. The angle at which this person should hold the umbrella with vertical, it is 10 alpha 3 by 4. Tell me, is it okay now? This is a simple
Yes,
trick.
ma'am.
Okay, this is a simple trick. That's it. It will help you to solve the question in lesser time. Is that okay to everyone, or should I explain it once more? Because is it, it's completely fine at my end. If
Ma'am,
you
will
have
you
some,
explain it?
please come again.
Ma'am, will you explain again?
Oh, okay. See, I said कि you will always have some kind of observation, ठीक है, which is going on in a question. For an example, in this question, I'm observing this rain. Let's consider कि I am this observer, ठीक है, who is holding the umbrella. Now I am moving with 30 kilometer per hour now. I will not consider myself in motion ever. For example, even if I am in a train, will I consider myself ki I am moving? I will always have this feeling na ki I am in stationary position because things around me are not moving. It is the tree which is moving behind. I will never feel ki I am moving ahead. Yeah, I am moving in the forward direction. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So similarly, here also, this person will not experience this 30 kilometer per hour on himself. He will say कि if this is the velocity of rain, which is 40 kilometer per hour here, then he will give his velocity in the opposite direction to rain. That rain is moving, behind 30 kilometer per hour, but rain is actually falling down with 40 kilometer per hour. So whatever the relative velocity that you will get now, it is the vector addition of these two velocities. This is your velocity of rain with respect to man. So basically, if you are moving, you are not supposed to be, you know you will not get this 40 kilometer per hour ever on yourself. You will get this vrm. So if you want to save from this, rain vagara, then you will open your umbrella opposite to this relative velocity. Okay, because in this direction you will getting this rain. Is that fine now?
Yes, ma'am.
Yes, ma'am.
So I think we should try with some another question. See, this is the velocity of rain, like this. Okay, rain is falling in this direction with 60 kilometer per hour. Here we have a person standing on a platform, and let's say this platform is moving in the forward direction with 80 kilometer per hour. Now again, the question is very simple. Keep find the angle at which this person should hold the umbrella. Okay, find it. And whenever I'm asking you find the angle, na, to it is always with vertical until unless I give you the description about horizontal one. Okay, solve it. Let me give you the time also. It's 14. Sorry, it's 16. It's 18:16 right now. You can give me answer within let's say 2 minutes. Okay, 18:18. Is question clear to you?
Yes, ma'am.
Okay, guys, you have 1 more minute to solve this question, and after that, I will ask. ठीक है? What are your answers? Okay, so Mishwa, can you start, beta? What is your answer?
When alpha is equal to 10, 6/8.
Okay. Shikha?
Ma'am, 4/3.
Okay. Mantasha?
Ma'am, 1 second.
Okay. Namrata?
Ma'am, alpha is equals to tan 1 minus 4 by 3.
Okay.
Yes, ma'am. By 3.
Okay. So that's okay. I guess Mishba, you are also right, but I think you get confused with perpendicular by base wala thing. Baki, um, Shikha, Mantasha, and Namrata. You got it correct. So this man is moving with 80 km/h. So what will he do? He will add his velocity in the opposite direction to rain. This is 60 km/h. He will add this thing like this. Okay, in this manner, 80 km/h. And you will get the relative velocity like this. Since 80 is greater than 60, then you will find that this resultant vector is, quite tilted around 80, more than this 60. Okay. So you need to find out this angle, which is alpha right over here. Just calculate it. Wait a second. It should draw properly like this. So basically, this is 60, okay, and this one is 80. So when I need to calculate 10 alpha, wait a second, it would be perpendicular by base, and it would be 80 by 60. So alpha would become 8 by 6, sorry, 10 inverse. It would be 10 inverse 8 by 6, which is 10 inverse 4 by 3. Okay? So this is your alpha. Yes. Now you can ask the questions. Haji Harshda.
Ma'am, why is shown it in the opposite direction?
Beta, because you are experiencing rain in this direction. So if you want to save yourself, you should open your umbrella opposite to it, na? Okay. I guess you are
Ma'am,
asking
but
about me this.
the velocity of the man is 80 kilometer and rain is of 60 kilometer. Eh?
Yes. But this is the concept of relative velocity. See, I
And
want to
then
calculate
the umbrella should be opposite direction, na? I'm saying in case of
of
right, it
this.
should be in left, na?
No. See, okay, just give me a second. If I want you to calculate velocity of rain with respect to man, what will you do? You will give me this thing, na? Ki ma'am, it is VR minus VM.
Yes, ma'am.
So velocity of rain is what?
60 kilometer.
Minus 60.
Yes.
And velocity of man is plus ka
Plus
80
80
I can.
I can.
But here you have a minus. So I think this vector is represented in this direction, right? As we draw over here, minus 60, minus 80. This is the direction in which you are observing the, rain. So you need to save yourself by open this umbrella in the opposite direction to this rain. You should open the umbrella against to the rain, na?
Yes, ma'am.
So that's why we are opening it in this direction, this alpha. I'm asking you to find the angle with the vertical. So that's why alpha. Otherwise, you can also answer in this way, ma'am, we will find beta. Then beta would be the angle with the horizontal. So it is according to the question. If question is asking alpha, then you will answer the alpha, otherwise beta. Is that okay?
Okay, ma'am.
Okay. So either you can go by book, or you can just whenever you are going to take an competitive exam, take a competitive exam, so you have to be very quick and fast with your calculations. So for that you can do this thing, you know. Otherwise, if you are comfortable with this way, then also it is fine with me. Okay.
Yes, ma'am.
Okay, now let's do a variation in this question. For example, this time rain is falling like this. Now rain is making some angle with horizontal. Let's say it is 37 degree and the velocity of rain is 50 kilometer per hour. Okay. Instead of falling directly towards the ground or vertically towards the ground, now it is falling at some angle. Here is the person, and this person is moving on a platform, let's say, right? And this platform is moving with some velocity 40 kilometer per hour. Now the question is still the same, ki find the angle with the vertical.
Can you repeat the question?
This time rain is falling at some angle. Okay, it is making 37 degree with the horizontal. This person is moving on a platform with 40 kilometer per hour. Now you have to find the angle in which umbrella should be opened. Is it okay? Have you got the question? Hmm? Beta, have you got the question?
Yes, ma'am.
Okay, that's
Yes,
good.
ma'am.
Yes, ma'am.
Haji, have you got the answer? Should I give you a hint? Batao? Do you need a hint?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
First, try to break these velocities into, you know, XX in I cap and J cap kind of things, right? It means resolve the vectors. And after that, try to calculate the relative velocity. Okay? First, break down these vectors into, in the I cap and J cap components. And after that, try to calculate the relative velocity. It will give you the answer. I'm going to give you 1 more minute and then I will solve this question. Okay, I think I should do this question now. See, this is the velocity of train, right? At 50 kilometer per hour. It is making this 37 degree with the horizontal. So I think I can write it as write it as like 50 cos 37 degree, and it would be 50 sine 37 degree. I know this magic triangle, and from there I could write the values of sine and cos. Sine 37 degree would be p by h, and it would be 3 by 5, and cos 37 degree would be b by h, which would become 4 by 5. So basically, you will have 50 into 4 by 5, which means 40 kilometer per hour in the x-axis, and 50 into 3 by 5, which means 30 kilometer per hour in the y-axis. Is that okay? So if I want to write,
Yes, ma'am.
VRG, it means velocity of train with respect to ground. It would be 40 I cap minus 30 J cap, right? And the velocity of this man with the ground is, I think, 40 kilometer per hour in the x direction, right? If I need to calculate velocity of train with respect to man, I will go with this expression. And as per this expression, you will get the answer. 40 I cap minus 30 J cap minus, and then velocity of man, which is 40 I cap. It is minus 30 J cap. So basically, you need to draw this velocity of train with respect to man. This is your Cartesian coordinate. And velocity of rain with respect to man is minus 30 J cap. It means in this direction, it is 30 kilometer per hour. So you are supposed to open your umbrella in the opposite direction to it, which means this time the angle with the vertical is 0. Is that okay? Is that okay?
Yes, ma'am.
So if I go by book, I need to do this much. But if I go with the trick, then trick would say This is the 50 kilometer per hour. It is 37 degree. I will resolve this vector into components right at this place. I will write it as 50 cos 37 degree and this as 50 sine 37 degree. I will got 30 kilometer per here per hour and 40 kilometer per hour here. Then I have this thing ki man is moving with 40 kilometer per hour in the forward direction. So if I know this concept that whenever there is a relative velocity, you will shift this velocity in the opposite direction to the rain. So what will you get? You will see ki 30 j cap. This is the y component of rain. And this is the x component of the rain. So whatever I'm drawing with blue ink, it is for rain. And when it comes to red one, so then it is that velocity which this person has. But as this person is, observing rain and everything, so this person will put his velocity in the opposite direction to the rain. And again, this is 40 kilometer per hour. There are two vectors which are equal in magnitude and they are in opposite direction. They will cancel out. And I'm left with minus 30 j cap. So I will open the umbrella in this direction and will get alpha directly. Without writing this much vector and doing this much calculation, I will get answer in a slide and in lesser time. So this is the trick. This is your competition. That's what I'm asking you to do, in the starting from the starting of the session. Now are we on same page or not?
Yes, ma'am.
So can you do the next question for me? Like I literally want everyone to raise their hand. Gayatri, Namrata, Anushka, Misbah, everyone. Shikha, Mantisha, Harshda, please do that. Do solve the next question. In this question, the rain is falling like this with 50 kilometer per hour and making angle 53 degree with the horizontal in this manner. Okay. There is this inclined road, something, and the angle of inclination is 37 degree. There is a person on the cycle. I'm not going to draw the cycle properly, but there is a person on the cycle or something, and this is moving with velocity 100 kilometer per hour. Okay. Now find the angle with the vertical. Okay, find the angle with vertical in order to get saved from rain. Okay, try to solve this question and I really want you all to give me the answer. Right now it is 18:36. I am giving you 3 minutes to solve this question. And the concept is very simple. Calculate velocity of rain with respect to this person by resolving into vectors, by using the trick or whatever. Just give me the answer. Hanji beta, have you got the answers? Like anyone? Hmm? So, do you know about the vectors? Have you completed basic mathematics?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Then
ma'am.
can you resolve these vectors into x and y components?
Yes, ma'am.
Yes, ma'am.
So, tell me what is the velocity of train with respect to ground in in I cap and j cap? Tell me the velocity. See, there is no point to discuss further, but if you are not getting it, can't you resolve this 50 km per hour into x and y?
We can, ma'am.
हाँ तो बताओ हर्षिता क्या आया? Velocity of train with respect to ground is what?
Ma'am, it's 50 cos 53 degree.
Yes, 50 cos 53 degree and 50 sine 53
50
degree.
sin 53 degree.
So, do you know about that magic triangle? You can find out the angles also, no? The value of cos and sine.
Yes, ma'am.
So, find out the value. See, you guys have to solve this question. I will
Ma'am,
not
cos
solve it.
value of cos 53 is 3 by 5 and sin 53 is 4 by 5.
Good. Now, put the value over there. Give me it in the, like the standard form. The standard form to answer any vector is this. For example, I want you to give me the value of vector A. Then you should answer me in this format, right? So, express velocity of train with respect to ground in this format. Harshda, you are very close to the answer. Solve it. What is you got the cos 53 degree, you got sine 53 degree. Just substitute the values and tell me the vertical and horizontal component of this velocity.
Ma'am, it's
Uh,
minus 30 I cap and minus 40 J cap.
uh, please come again.
Minus 30 I cap and minus 40 J cap.
Exactly, that is very good. Just hold it. I'll write it down. See, this is 50 km per hour, making angle 53 degree with the horizontal. When you break this thing into vectors, then it would become 50 cos 53 degree, and this would be your 50 sine 53 degree. The value of sine 53 degree is 4 by 5, which makes it 40 km per hour. And the value of cos 53 degree is 3 by 5, and it will give you 30 km per hour. Once you get these angles, now can you write it in this form now? That velocity of train, what is the AX in this thing? 30 km per hour now. It is in
Yes,
negative
ma'am.
x, so you will write minus I cap. Then AY is this 40 km per hour, and it is in negative y direction, so it would be negative of j cap. That's it. This is your vector. Can you do same with this velocity, with the velocity of man?
Yes, ma'am.
Yes, ma'am.
Yes, resolve this vector also and give me the velocity of man with respect to ground.
Ma'am, it's 80 I cap plus 60 J cap.
Okay, good. See, the velocity is like this: 100 kilometer per hour, making 37 degree with the horizontal, right? Just a second. Making 37 degree with the horizontal. So you can break the components in this way: 100 cos 37 degree and
100 sin
100
37 degree.
sin
100
37
sin
degree.
37 degree.
What is the value of cos 37 degree?
4 by 5.
4 by 5.
Very good. So it would become 80 kilometer per hour. And this would become 100 into 3 by 5, which means 60
20
kilometer
kilometer.
per hour. 60, huh? So if I wrote it, if I write down this one in the form of vector, then velocity of man or person would be 80 I cap.
Plus 60 J cap.
Yes. Now you have velocity of man as well. As well as you have the velocity of rain. I think now it is very simple to calculate the velocity of rain with respect to man, because it is VR minus VM. So VR is minus 30 I cap and minus 40 G cap. You are supposed to subtract this from 80 I cap plus 60 J cap. Just solve this thing. And you will get minus 30 minus 80, it would be minus 110 I cap. Minus 40 minus 60 is minus 100 J cap. Just draw this vector on the Cartesian plane. I guess you will get minus 110 like this in this direction and 100 in this direction, right? I want to calculate the resultant one, so it would be like this. Zyada difference nahi hai, so it will go somewhere here, right? I need to open the umbrella in this direction. This is your alpha calculated. Tan alpha would be perpendicular by base, and that is your 10 by 100, and it gives you alpha as tan inverse 11 by 10, right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Do you guys have 10 more minutes? Can we elongate this class to like further 10
Yes,
more
ma'am.
further minutes? Okay.
Yes, ma'am.
I want to discuss one important phenomena with you, and that is river swimmer problem. In this kind of questions, you will have a river, okay, with some perpendicular distance, which which will call as width of the river. Then this river may have a water current. It means velocity of a river, and there would be a swimmer. Okay, let's consider two observers over here. One is in the river and one is on the ground. So let's say this is observer A, this is observer B. This is your swimmer. Okay, so this swimmer wants to reach just vertically opposite to his position, right? He is at this bank. He wants to reach here just perpendicularly opposite to his initial position. But you know, whenever this person try to swim in the perpendicular direction, just wait a minute. If this swimmer tries to swim in this direction, this current will also displace this person now. This swimmer tries to cross this river perpendicularly, but this river will swim him in its direction also. It
Yes,
means
ma'am.
the motion is going to be like this. This person wants to approach position C, but he will somehow get drifted to position let's say D. Yes or no?
Yes, ma'am.
Yes, ma'am.
So this CD is known as drift. Okay, drift is basically what is the displacement from point C to the because this is the position which this swimmer wants to obtain, but due to velocity of river, this swimmer will get drifted from point C to point D. Okay, so the distance in between these two positions is called drift. D is the width of the river. Now there are two things. This person A, he will observe this, I should mark it also. Let's say this is S. Huh? So this observer A will see that this swimmer follows the SD trajectory, right? This person A will observe that person, this swimmer swim from S point to D point. But the observer who is also in this water will see that this person moves from S to C. Why? Because this person is also moving with VR now. So he will not going to feel this velocity of river, right?
Yes, ma'am.
Yes. So there are two things now. This perpendicular velocity is VSR, velocity of swimmer with respect to river, and this SD is velocity of swimmer with respect to ground. Are we okay with this?
Yes, ma'am.
Pakka? We are going to follow the same story in all questions, right? Whenever a river swimmer problem will come, we will follow the same story. For example, here we have a question. Let's say this is the river. Okay. And the water current is 3 kilometers per hour. The width of this river is 16 kilometers. We have a swimmer over here, and this person wants to approach the position A. Okay? But somehow he will reach to position B. Now you have two things to find out. Find the time taken to cross the river. Second thing, at what position will swimmer arrive? Okay? And you have one more information, that velocity of swimmer with respect to river is 4 kilometers per hour. Can you solve this question? This is the last question of today's session. It is 18:52 right now. You will have 2 minutes to solve this question, and then I will discuss it. Please confirm once ki have you got the question? Okay, that's cool. Time is up. Have you got the answers? Anyone? Should I give it a try? Hmm? You need to respond. Am I audible? Hello.
Yes, ma'am.
Yes, ma'am.
To kindly respond, bacha. Do you want to solve it further, or should I give you the answers? No? Take it as your homework, solve it, and then we will deal with it in the next class. Okay, I will tell you one more thing. Ki in next class, we will deal with these few questions, reverse humor problem, and then we will move towards circular motion. See, from now onwards, you will get more complicated mathematical things now. So please, it's my suggestion ki please go and watch those basic mathematics videos, or just do it from anywhere, literally. Just do this. It is very important, because at this point of time, you are supposed to, you know, do all the resolution of vectors and everything, vector addition. I think you're supposed to be very, very good into this. So just do this. Okay, please do this basic mathematics. Solve at least 10-20 questions out of it. It will help you to understand all the topics quite better. And the other thing is, the pre-work would be revise your all variables of motion, right? And equation of motion. Basically, revise the kinematics, because it will help you in rotational motion. Okay? Is that okay?
Yes, ma'am.
Okay. Thank you. We'll see you in the next class. Bye.
Thank you, ma'am. Bye, ma'am.
Bye-bye.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Ma'am, could you
Ma'am,
attendance?
attendance.